What questions do you have on 1 through 8? These should be problems that you can do, like it just takes you a minute to figure it out and then you can answer it. Okay, these should not require a lot of thought. So if it's still taking you a lot of thought, then you need to practice more, which I will give you another assignment on this sometime, probably after the next quiz or something. But on number 3, you can write it either way, but remember that if I ask you to multiply that out, that is not x squared plus 4, right? You have to write it down twice like that and then FOIL it out, which would give you that back. So if you write the quantity squared, that means you'd have to write it down twice and you do FOIL. Okay, none of those had a greatest common factor, but then later on, I think there were some. Okay, yeah, number 10, 12, actually all of those had a GCF, right? What does GCF stand for? Greatest common factor. Jaron, what does it mean to have a greatest common factor? Does it have to be a number? Like on that one right there, that's not a number, right? It doesn't have to be a number. It has to be like a number or. Yeah, that's what they have in common. It could be a variable or a combination of a number and a variable. But yeah, it's like when you do a factor tree and you're breaking a number down into the values that would multiply back together to give you that number you started with. So you're looking at these and you're saying, what could I take out of both of those terms? And what is the biggest thing I could take out? So if you just took out a 2, you haven't taken out, the most things. So you want to look at the numbers and take the GCF, and you also want to look at the variables and take it out the GCF. It's got to come out of every term. If there's something that divides out of 2 of the terms and not the third, then it's not a common factor. Okay, so before you do factoring, like the trinomial type factoring, you always look for the greatest common factor, and then it'll make it a lot simpler if there is a GCF. Okay, so all of those turned into polynomials. That one didn't even factor anymore, but polynomials that are easier to factor because you can take out that front number. Do you remember what you call the kind that looks like that? X squared minus 64? Or like m squared minus 100, or like y squared minus 9. Yeah, and it's subtraction. When there's 2 terms, they're both perfect squares, it's called a difference of squares. That's kind of one of those like patterns you want to notice. The kind of formula type of thing. They'll say a squared minus b squared equals a minus b times a plus b. That means take the square root of that thing and put it there and there. Take the square root of that thing and put it there and there. And then you get 1 plus and 1 minus in order for the product to be negative b squared and also the middle terms to drop out. So a plus ab and a minus ba will cancel. Okay, so a difference of squares always factors like that. So if you had x squared minus 100, who can factor that for me? X plus 10, x minus 10. Thanks, Jerome. Okay, so again, difference of squares should be one that kind of jumps out at you. If there were, let's say that there was like a 4 in the front there, what's the first thing you would do? Find the GCF. So it would become 4 and then x squared minus what? Minus what? Nope. Jaron, take a break. Somebody divide that by 4. What is it? 25. 25. Okay. Okay. And then, Michael, can you tell me the next step? Yeah. So what would it be? Oh, you mean the same thing? No, it does break down more. That's not the last step. There's one more step. Kara? X plus 5, x minus 5. So again, this is a difference of squares. Both of those things are perfect squares. So we'll take the square root of x squared is x times x. The square root of 25 is 5 and 5. We need 1 plus and 1 minus, again, in order for it to multiply to negative 25, but also your minus 5x and your plus 5x have to cancel out. So when you check that, it's x times, oops, it's x times x is x squared. That's a minus 5x. That's a plus 5x, and that's a minus 25. So these guys cancel out, and it gives you back what you started with. That 4, you just kind of carry it along there, and then you can distribute it back. Okay, but that's when there's 2 terms, and these are both perfect squares, you got to factor it down into a difference of squares. Up here, even though those are perfect squares as they are, so let's say, this is kind of a common mistake. Let's say that you notice that those are both perfect squares. Let's say you notice that those are both perfect squares, and you break it down into, so this is if you don't take out a GCF first. Those are both perfect squares. So how would that break down if you didn't take out a GCF? Carrie already gets their question. Somebody else? Blair. Let's just do the 2x part first. Okay, 2x times 2x is 4x squared. It's not 25. It's a perfect square, right? Yeah, minus 10 and plus 10. Now, I had told you that it was going to be this, 4 times x minus 5 and x plus 5. Why aren't we getting the same answer there? Because it's not all the way simplified. So if you do not do a GCF first, you might forget about it. See how there's still a GCF in here? What is the GCF? 2. Right, and there's still a GCF in that one also. There's also a 2 in there. Oops, sorry, back that out. And that's the same thing as what we had here. But you always want to look for a greatest common factor first, because then you won't forget to take it out later on if it's still kind of embedded in there. Blair. Yeah. So you have that, right? Okay. The problem is this is not an equation. So if it was an equation, you could have that equal to, well, sorry, up here. You could have this equal to 0. And then you could, so let me recopy it. 3n squared plus 33n plus 90 equals 0. You could divide everything through by 3, and that would not be a problem because it's an equation. If you multiply the left side by 3, multiply the right side by 3, you're going to get your n squared plus 11n plus 30 equals 0. This is not an equation, which means you can't divide through like on both sides of the equation. What you have to do is just kind of manipulate what's already there. That 3 can't go away because there's nowhere to put it. That's why it's sitting out in front. When we say factor it out, we are dividing it out, but it still has to be there because remember, when you're checking factoring, you've got to be able to multiply this back together and get back where you started. So if you lost that 3, there wouldn't be any way to get back to the original problem because you'd be missing that 3. Okay, so with an expression, when you're thinking like divide out the 3, think of it like factoring it out because it's got to sit there in the front. Does that make sense? The difference between an equation and an expression. Okay, the backside was equations. Let's jump back there. Okay, so for this one, were there any GCF in that one? Yeah, so you could have started these by dividing out a GCF. It looks a little different than how I did it, but we'll get there in a minute. There's a kind of a common thing that students want to do, which is take something like this and turn it into a squared equals 4a, and then try to square root. That's not going to work. Okay, with solving by factoring, you're always trying to get it equal to 0. And that's always how you want to start. I'll leave that there and stop moving it around. Okay, so remember the difference between the problems on the front and the problems on the back is the problems on the back are equations, which means you can actually solve and find a variable. On the front, you're just breaking it down. Questions on 15 through 18? Again, this is all algebra review, but again, I know some of us, I mean, factoring is something that like you're gonna see again, a ton of it in algebra 2. And you know, we're expecting you to understand the basics, and our hope is that in geometry you get a little better at it, and then when you see it in algebra 2, you're not starting from scratch, right? You're kind of like, okay, I kind of remember this, just need to practice it more because the problems start getting harder in algebra 2. Okay. Factoring is one of those things that at first some students just really don't kind of understand what's happening, and the more you practice it, hopefully the easier it gets and it starts making more sense. Okay, for the bottom two, if you wanted to start, so I'll kind of show number 19 in a way like what Blair kind of asked. So if you did 2r squared minus 18r plus 40 equals 0. Because it's an equation, you can divide through. The reason I didn't do it this way is because I don't want you to lose that 2 if you're just factoring. But if it's an equation, this is only something you can do if it's an equation. You can divide through by the GCF. And it kind of gets absorbed by that 0 on the other side. And then you'll have r squared, r squared minus 9r plus 20 equals 0. And then you can factor, and you don't have to worry about that 2 in the front. Okay, so that's your r minus 5, r minus 4. And then you get your 2 answers, r equals 5, r equals 4. So you can only do this if it's an equation. Again, that's why I wrote it this way up here. But it doesn't matter which way you do that, as long as you understand that it's only going to be possible to divide like this if you're dealing with an equation. If you take a screenshot of that, feel free. I guess a picture of that.